This video is on the objective understand the process of hypothesis testing. This is the second video I'm making on a question related to this objective from your Newton-Alta homework. And in it, I'm going to do the same thing I did in the first video. I'm going to take you through, and I'll do this in a lot of videos, as you'll notice, because I really want you to get the steps down in the process of hypothesis testing, because we are going to be performing hypothesis tests for the rest of the course. So understanding how that is done, understanding the process, knowing what comes when, what steps you're performing, is very important. So here's the question. But again, first, before I get into this, I want to go over the process again. So same page I drew up earlier. Right? So this is the process of hypothesis testing. So I'll go through it a little more quickly this time. So one, a claim is made about a parameter, right? A claim, some claim about some aspect of the population is made. Then based on that claim, hypotheses are formed, two opposing hypotheses, two contradictory hypotheses. One's called the null hypothesis, H0. One's called the alternative hypothesis, HA or H1. And how these are formed will be discussed in another video. Then after this, we identify a significance level. This significance level is called alpha. And as I've mentioned before in other videos, in another video we'll discuss what it means to make a type 1 error when performing a hypothesis test. And this value alpha, this significance level, is the probability of making that type 1 error. And we'd like this to be pretty small, right? The probability of making an error. So usually this is set at like 5% or less. Depends on what you're looking at. Depends on how tolerant you wish to be, right? Or what your threshold is. Third, a sample is taken, or samples are taken from the population. And from those samples we calculate a test statistic. Now it's usually a z-score or a t-score or a chi-squared score or whatever. It depends on it all depends on the sampling distribution you're looking at. Or if it's even a distribution type test at all. There are distribution free tests called non-parametric tests, but that's neither here nor there right now. So if the distribution of the sample means is normal, we'll use a z-score, or proportions is normal, we'll use a z-score. If we're looking at a student's t-distribution with so many degrees of freedom, then our test statistic will be a t-score. But a test statistic is calculated. Right, then from there you have two options. You can either perform a hypothesis test using the critical value approach or the p-value approach. Now, if you are using the critical value approach, after that test statistic is calculated, you determine a critical value or critical values, and those will depend on what kind of distribution you're looking at. And that'll help you set up a rejection region, something called a rejection region. And you compare these critical values to your test statistic. And depending on how they compare, then you'll make a decision. Step 5, you'll make a decision on whether or not to reject that null hypothesis. You'll either reject it or you won't. And it's again based on how the critical values compare to the test statistic. Then you decide to reject or not reject, fail to reject the null hypothesis, and then from there you state your conclusion. And the conclusion will be about the initial claim. do you have enough evidence to support the initial claim or not support the initial claim. Now, if you decide instead to use the p-value approach, it's pretty similar, but instead of finding critical values, you're going to be determining the p-value of your test statistic. And like critical values, the p-value will depend on whether or not the test is left-tailed, right-tailed, or two-tailed, and we'll get into that in another video. How do you determine that? And you're going to compare this p-value to the significance level that was mentioned earlier, that alpha. And then depending on how the p-value compares to alpha, then you make your decision about the null hypothesis. Do you reject or fail to reject the null hypothesis? And then once you've made that decision, you state your conclusion. Do you have enough evidence to support the claim or not? So again, same. I've gone over these steps in several videos now, and I'm going to continue to go over them in other videos too. I want you to get these steps down. I want you to know them very, very well, because you're going to be doing them a lot. Okay. So back to the question. So Katie would like to start a small business. As she writes out her business plan, she's interested in the average number of years until a business turns a profit. So based on previous research, it takes 5 years on average for a small business to turn a profit. But Katie believes, again, keyword here is believes. Katie believes that this average is different. She believes that the average number of years a small business takes to turn a profit is not 5. It's different than 5. So her claim, that first step, her claim, her belief that she wishes to test, her claim would be that the average number of years it takes for a small business to turn a profit is different than 5 years, is not 5 years. All right, then she'd set up 2 hypotheses. One would be the claim. That would actually be the alternate hypothesis. Alternative hypothesis, again, we'll talk about how to form the hypotheses in another video. And then the other would be, all right, so one hypothesis would be the average is not 5 years. The other hypothesis would be that the average is 5 years. Right? They oppose each other. And she'd say then her significance level, alpha, again, if it's not mentioned, we'll just say 5%. Then she takes a sample of small businesses, see how, maybe takes an average for that sample. Then from that average, calculates a test statistic, a z-score or a t-score for that sample's average. And then it says here, if Katie chooses a critical value approach, what does the critical value need to be compared to in order to determine if there's enough evidence to support her claim? And I've mentioned, you're going to compare critical values to that test statistic. All right, you're going to compare critical values or a critical value or critical values to the sample's test statistic. Now the p-value is a totally different approach. P-value will be compared to alpha, all right, in order to make your decisions, your conclusions. The p-value will be compared to the significance level. Hypotheses are formed from the claim, right? And again, like I said, the p-value and significance level, those will be compared if you choose to do the p-value approach. But in the critical value approach, critical values are found based on the distribution you're looking at. Is it normal, students t with so many degrees of freedom? And then you compare your test statistic to those critical values and make your conclusions, make your decisions. All right. So again, this is just understanding the steps as I've laid them out for you. And as they're described when you click, again, when you click on more instruction here, when you look at what Knewton Alta has to provide for you in terms of instruction, they have the same steps as well. I think I broke up the fifth step into two parts, where you make a decision, then you make a conclusion. I think they put all that together. I personally like having that be two different steps. Yeah. So again, pay attention. Are they talking critical value approach? Are they talking p-value approach? Because it will make a difference. It will make a difference into what values are you comparing to then make your decisions, make your conclusions. Right. All right. So hopefully this video helps in when you're looking at a question related to this objective on your own. And I didn't cover, I didn't cover everything here. I'm just going over the basics, right? The 6 basic steps of hypothesis testing. We'll delve into these steps further in future objectives, future videos. And thank you very much for watching.